Namaste. Myself, Sachchida Nand, Assistant Professor, Mechanical Department, with the Institute of Technology. As we are in the continuation of the last lecture, where we left these things, so understanding the extension graph of ductile material, that is how this particular material is behaving, and by this we can examine the ductile property of that material that will go through the universal testing machine. As in the previous lecture, in the continuation of this, we had discussed that how this particular graph is to be made, and this particular graph, it's not like we need to draw it by our hand. This particular graph is automatically drawn by the machine, which is the reflection of the behavior which a material is possessing during the tensile load applied on it. So, as in this particular figure, as I told you, this particular block is fixed. This is the movable one, and the particular workpiece is held here. And this is the particular cylinder where the graph is to be made. A paper roll is attached here, and there is a pen is also attached here at this point. So the tip of that particular pin is touching this particular cylinder's paper, and it start with the starting of that particular load applied by this particular hydraulic machine on this particular material by extension of this particular jaw in the opposite directions. So when the load is applied, this particular graph is starting to draw, and gradually it is showing what is happening with this particular material that is drawing onto this paper. And that's the thing finally we get after breaking of the material. This is the breaking point, and that is how the netting is done, that is showing. And this is the initial phase machine workpiece. So these are the things are maintained here. That is, according to these things, this kind of data analysis is taking place, and behalf of this graph, we examine the behavior, the tensile strength or the ductility of that particular material. So, we will come back to this particular slide again, and for that we need to go through the total working procedure of this universal testing machine. So we will discuss this after the discussion of that particular detail. So this tensile test methodology is need to be identified by the various kind of case studies or by the testing methods, that how this particular tensile test is happening and what are the things this particular tensile test is possessing. So again, the introduction of this tensile testing. These tensile tests are performed for several reasons. The result of tensile tests are used in selecting materials for engineering application. As we are discussing that as per the requirement of that particular material, what are the various requirements of that particular material? In the previous class that we talked about, that is a wire bridge. So what is the requirement of that wire which is related to this particular test? As if you focus on that particular figure of that particular bridge which is hanging by that particular wires, so that wires are very hinged very tightly and to hold the load of that particular bridge. So when the loading and unloading is happening, there is a stretching and compression is taking place in that particular material. And that's why, and that's the requirement of that particular material to must go or to must pass the tensile test for their application. So, the tensile property frequently are included in materials specification to ensure the quality. What is the quality and why it is required? It is required because the material which we are choosing for making any product or wire is also a product, for working in their working environment. So it must possess this kind of things. So the tensile property often are measured during development of new material and processes, so that different materials and processes can be compared. That it should be identical, and if we are designing or manufacturing any new material, it should be made by different kind of processes, and after that it should be analyzed and to compare that which particular processing is better for maintaining this particular property. So that is how this particular material engineering is basically working. So after the comparison of that particular which is made by different processing, finally the tensile property often are used to predict the behavior of a material under form of a load other than uniaxial tension. So the strength of a material often is a primary concern, and the strength of interest. So the strength of interest may be measured in terms of either the stress which is necessary to cause applicable plastic deformation or the maximum stress that material can withstand. So these are the two conditions. So these are the two conditions on which we need to focus regarding making any material. So that how much that particular material possessing the stresses, or how much that particular material withstand with that stresses. So in both way in the coexistence, either या तो वो bear करेगा उस stress को, और या फिर withstand करेगा उस load को. So these are both are in the similar way. So the plastic deformation, that particular measure in terms of either that particular stress necessary to cause applicable plastic deformation. So means अगर कोई मटेरियल है, अगर उसके ऊपर में स्ट्रेस लगा रहे हैं और वो अपने आप को प्लास्टिक डिफॉर्मेशन में तब्दील नहीं करता है, अपने डक्टिलिटी को इलाज नहीं करता है, तो वो इस पर्टिकुलर थिंग को फुलफिल नहीं करेगा. एक कंडीशन. दूसरी कंडीशन क्या है कि अगर किसी मटेरियल के ऊपर वही सेम चीज कि मैक्सिमम लोड भी लगा रहे हैं, तो कितना लोड को वो सह पा रहा है, टेंसाइल लोड को अपनी स्थिति को बनाए रखने के लिए। तो ये दो कंडीशन को ध्यान में रखना बहुत जरूरी है। तो इसीलिए ये कहा गया है द स्ट्रेंथ ऑफ इम्प्रेस may be measured in terms of either the stress necessary to cause applicable plastic deformation. Plastic deformation means we have a single lot of material and we are extending that material in the roller for making a thin wire. So what is happening in that thing? That during the making of that wire, so wire we can make wire by the two methods also. That is by the rolling or by the beating. So which one is better one? That will depend after the testing of that particular material. अगर हमने किसी दो मेथड से किसी एक पर्टिकुलर प्रोडक्ट को बनाया है और उसकी स्ट्रेंथ को हम जब जानेंगे कि किस मटेरियल से बना हुआ प्रोडक्ट ज़्यादा स्ट्रेस को विथस्टैंड कर रहा है और बनाते समय कितना ज़्यादा लोड को सह पा रहा है और उसको कितना ज़्यादा वो बियर कर पा रहा है, and that is why this particular ductility and the tensile testing is to be happened. And these measures of strength are used with appropriate caution and in engineering design. So in the form of the safety factor. So that how much that particular material is sustaining the load. कि उस particular material के ऊपर कितना खिंचाव या दबाव दिया जा रहा है जिसको वो सह पा रहा है और अपनी स्थिति को मेंटेन करके रख रहा है। अगर उसके ऊपर खिंचाव हो रहा है तो उस खिंचाव के प्रभाव में आके वो कितना अपने आप को आगे बढ़ा रहा है और बढ़ाने का क्रम ये है कि अपनी स्थिति को वो तोड़ नहीं रहा है, अपने फैक्टर को मेंटेन किए हुए है। और तभी जाके हमें पता चलेगा कि कितना पर्टिकुलर मटेरियल स्ट्रेस को व्हेन the both end of that particular material is affected by the loading separate. तो टेंसाइल टेस्ट का यही मुद्दा है कि अगर हम किसी मटेरियल के ऊपर दोनों तरफ से लोड लगाते हैं तो वो मटेरियल कितना स्ट्रेस को बियर कर सकता है, अपने अंदर फोर्स पर यूनिट एरिया को अपने अंदर कितना बेयर करके अपने आप को फैला सकता है, इलोंगेट कर सकता है और इलोंगेट करते करते कितना वो स्ट्रेस को सहने की क्षमता उसके अंदर होगी कि बिना टूटे हुए, बिना अपने आप को डैमेज किए हुए वो अपने आप को स्ट्रेच करता जा रहा है। लाइक अ बबल गम। आप बबल गम को खाते हैं, उसके बाद मुंह में से लेकर उसको एक्सटेंड करते हैं, एक्सटेंशन होता है, दैट इज द पर्टिकुलर थिंग, दैट इज द डक्टिलिटी। और होता क्या है, एक टाइम के बाद वो टूट जाता है। तो जो उसके एटम्स के अरेंजमेंट्स होते हैं, जहां तक अपने आप को बैलेंस करते हैं वो बैलेंस करते जाते हैं और जब उनके बीच की डोर जो टूट जाती है और वहीं वो खत्म हो जाता है और वहीं पे उसका मैक्सिमम टेंसाइल स्ट्रेंथ पता चलता है। एंड दैट इज द थिंग वी आर डूइंग इन दिस पर्टिकुलर टेंसाइल टेस्ट कि मटेरियल के ऊपर अगर हम खिंचाव दे रहे हैं तो उस खिंचाव के प्रभाव में मटेरियल कितना अपने आप को स्ट्रेच कर रहा है, कितना अपने आप को फैला रहा है और फैलाते समय अपनी स्थिति को मेंटेन किया हुआ है, कहीं से भी उसका कोई रेशा नहीं टूट रहा है। और जब अपनी स्थिति को बैलेंस नहीं कर पाया वो एट लास्ट क्या हुआ कि वो फिर टूट जाएगा। तो जहां टूटेगा वहीं पता चल जाएगा कि अब ये पर्टिकुलर मटेरियल की ये मैक्सिमम लिमिट है और इस पर्टिकुलर मटेरियल को हम इस पर्टिकुलर टेंसाइल लोड तक यूज कर सकते हैं और तब जाके हम किन्हीं मटेरियल्स को किसी ब्रिजेस में, किसी पुलीज में, किसी स्ट्रक्चर्स में यूटिलाइज करते हैं। तब जाके एक सस्टेनेबल, एक बेटर प्रोडक्ट हमारे इन्वायरमेंट में सेटल्ड हो पाता है और जिससे हम एक फैक्टर ऑफ सेफ्टी की जो बात कर रहे हैं, जिससे हम निश्चित होकर उस ब्रिजेस के ऊपर से बड़े आराम से चले जाते हैं। लेकिन अब इसके बाद अगर कहीं किसी ब्रिज के ऊपर से जाइएगा तो उसके ऊपर जो भी उसको बनाने में जितने भी मटेरियल लगे हैं और जैसे जैसे आप पास होइएगा और अपने लोड को उस मटेरियल के साथ कनेक्ट करके देखिएगा कि वो मटेरियल किस तरह के लोड को सह रहा होगा, तो आप समझ पाएंगे कि कितना इंट्रिकेट है, कितना इंपॉर्टेंट है इस पर्टिकुलर प्रॉपर्टीज को समझना और टेस्ट को परफॉर्म करना। अगर आप किसी पुल पे जा रहे हैं और पुल के अंदर वो क्षमता ही नहीं है उस पर्टिकुलर लोड को सहने की, क्या पुल विथस्टैंड कर पाएगा? पुल पे चढ़ते ही पुल धंस जाएगा। लेकिन कुछ पुल अभी भी ऐसे हैं, जैसे कि मैंने पहले देखा था हावड़ा ब्रिज, वो अभी भी विद स्टैंड कर रहा है। ऐसा क्या है उस मटेरियल में? ऑब्वियसली उसको ऐसी टेस्टिंग की गई और उसमें कुछ ऐसे मटेरियल्स को यूज किया गया जो आज के डेट में भी सैकड़ों सालों से खड़ा है वहां पे और हावड़ा टू कलकत्ता को जोड़ रहा है। तो वो हुआ कैसे? जस्ट बिकॉज ऑफ दिस काइंड ऑफ टेस्ट के बिहाफ पे हमने आइडेंटिफाई किया कि यस, ये मटेरियल इतने लोड को इतने देर तक सह पा रहा है। और उसी के साथ उन सब चीज़ों को हमने एक बोलते हैं इंजीनियरिंग की मिसाल कायम करते हैं। तो वो मिसाल बनती कैसे है? टेस्टिंग बाय टेस्टिंग, डिफरेंट काइंड ऑफ टेस्टिंग, डिफरेंट प्रोसेस से बना हुआ मटेरियल को डिफरेंट तरीके से टेस्ट किया जाता है। और वो टेस्ट करने के बाद जब फाइनल होता है कि नहीं, दैट इज द परफेक्ट वन, कि इस प्रोसेस से हम मटेरियल को बनाएंगे और इस तरीके से ये टेस्ट करेंगे, तब जाके हमें फाइनल रिजल्ट मिलता है। और जब वो फाइनल रिजल्ट सेटिस्फाइड होता है सारे रिजल्ट के कंपैरिजन में कि दैट इज द बेटर वन रिजल्ट, तो उस प्रोसेस को फॉलो करके उस पर्टिकुलर मेटल को बनाया जाता है, टेस्ट किया जाता है और कंपोनेंट को बना के यूज किया जाता है। So in this particular thing in engineering design, so also interest the material ductility, which is measured of how much it can be deformed before it fracture, which I told you earlier, that the point I discussed earlier, कि कितना अपने आप को खिंचवा सकता है, वो कितना अपने आप को खींचते समय लोड को बियर कर सकता है बिना टूटे हुए। And that is how this particular tensile strength is to be identified of that particular ductile material. Right. So rarely is ductility incorporated directly in design, rather it is included in material specification to ensure the quality and the toughness. So this point is showing another kind of a thing, that the बहुत rare होता है कि ductility डायरेक्ट डिजाइन को डिफाइन करके हम आइडेंटिफाई कर देते हैं बिना उसके मटेरियल के स्पेसिफिकेशन को आइडेंटिफाई करे हुए, बिना उसके टफनेस को आइडेंटिफाई किए। सो इट शुड बी आइडेंटिफाइड ड्यूरिंग दैट पर्टिकुलर थिंग्स मेकिंग। So low ductility in a tensile test often is accompanied by low resistance to fracture under other form of loading. And the elastic property also may be interesting, but a special technique must be used to measure these properties during the tensile testing. And more accurate measurement can be made by the ultrasonic technique. That is how this is the another kind of a process by which have the material which have the low ductility, which how that can be examined by this kind of advanced techniques. So that is to be measured. Now how that is measured? That particular figure which I told you in earlier class also, that is tensile specimen and testing machine tensile specimen. You consider the typical tensile specimen which is showing in this particular figure, and that particular slide having that particular dimension which is showing that particular gauge length. That is are either of the two type, either in the flat sheet or in the circular bar, which we discussed in earlier. So in the figure the specimen is shown and it has the enlarged end of shoulder for gripping. Why this particular shape is provided? Because to hold that particular material in that particular testing machine in the jaws properly. आपने देखा होगा जो मैंने यूनिवर्सल टेस्टिंग मशीन का फिगर दिखाया था, उस यूनिवर्सल टेस्टिंग मशीन में दो जॉज थे, एक जॉ फिक्स था, एक जॉ मूविंग था। तो दोनों जॉ में वो प्रॉपर तरीके से फिक्स हो जाए, इसलिए ऐसे हम पर्टिकुलर शोल्डर्स को प्रोवाइड करते हैं। So the cross section area of the gauge section is reduced related to the remainder of the specimen, so that the deformation failure can be happen in that particular gauge length. As we discussed that these particular things are holdable in that particular jaws, and the total measurement is taking place in between these points only. That's why we mentioned this gauge length according to the ASTM standard. And all the fracture mechanism, fracturing of that particular material is to be happen only in this area. So the typical tensile specimen showing a reduced gauge section and enlarged shoulder to avoid end effect from the shoulder. अगर shoulder को चौड़ा इसीलिए बनाया हुआ है यहाँ पे इसीलिए कि जो फोकसिंग ऑफ लोड है, जो स्ट्रेसिंग ऑफ लोड है, इस पर्टिकुलर रिड्यूस्ड एरिया पे ज़्यादा से ज़्यादा फोकस हो सके, न कि ये यहीं पे लोड लगे और यहीं से ब्रेक कर दे. So the length of the transition region should be least as great as the diameter, and there the total length of reduced section should be least 4 times the diameter. So that is how this things to be made, and that is to be examined by this particular universal testing machine. So these are the various jaws, how that particular things are to be grabbing in that particular jaw. So systems for gripping the tensile specimen, for round specimen, these include the threaded grips. The first one is the serrated wedges, and for butt and specimen split collar constrained by a solid collar, and the sheet specimen may be gripped with the pin that is showing in the D section, or serrated wedge in the E section. So this particular, as I told you, that engineering is very vast. According to requirement of everything, we change everything. So आप देख सकते हैं कि अगर मटेरियल का शेप एंड साइज अलग अलग है, उसके हिसाब से भी पर्टिकुलर उसके ग्रिपिंग एरियाज को भी आइडेंटिफाई किया गया है कि किस पर्टिकुलर ग्रिपिंग एरिया में वो बेहतर तरीके से उसको ग्रिप करेगा और जिसकी ग्रिपिंग की वजह से जो लोड है वो इक्वली डिस्ट्रीब्यूट. So localizing this region, the gauge length is the region over which the measurements are made and the center within the reduced section. The distance between the end of the gauge section and the shoulder should be great enough so that the larger end do not constrain deformation. And that's why there are the various way of gripping of this particular specimen. So there are the various way of gripping the specimen, some of which are illustrated in this figure. And the end may be screwed into a threaded grip, or it may be pinned. That is the pin. That is the last. So, but it may be, or the grip section may be held between the wedges. And the most important concern in the selection of a gripping method is to ensure that the specimen can be held at the maximum load without slipping or failure in this grip section. Bending should be minimized. Bending should be minimized when the load is applied, and that the thing is to be measured, and that the thing is to be in the consideration. That's why this gripping section is to be identified and which condition that has to be designed to maintain the buckling or the shifting of that particular specimen. अगर हम इस ग्रिपिंग को बेहतर नहीं करेंगे तो क्या होगा? हो सकता है जब लोड लगाए तो वो स्लिप कर जाए, हो सकता है कि लोड जब लगाए तो वो ट्विस्ट कर जाए, हो सकता है लोड अगर लगाए और ग्रिपिंग सही ना हो तो वो पर्टिकुलर बेंड हो सकता है, मूव कर सकता है, टेढ़ा हो सकता है. तो स्पेसिमेन जो हमने बनाया हुआ है वो बेकार हो जाएगा. तो इंडस्ट्री में एक बात का दो चीजें बहुत मायने रखती है, एक सेफ्टी और एक इकोनॉमी, और दूसरा टाइम, तीसरा टाइम. तो ये तीनों एक साथ काम करते हैं. तो अगर आप किसी स्पेसिमेन पे टाइम लगा रहे हो, पैसा लगा रहे हैं और उसको टेस्ट करने के लिए उस पर वर्क कर रहे हैं, अगर वो वर्क का टाइम खराब हो गया, इट मींस यू वेस्टेड लॉट्स ऑफ मनी एंड लॉट्स ऑफ टाइम. और अगर आपने सेफ्टी नहीं मेजर किया तो वो चीज ऑब्वियसली वो गड़बड़ होगी. एंड दैट्स व्हाई दिस थिंग नीड टू बी प्रिसाइज टू मेंटेन एवरी टाइम, everything. And that's why a standard product is to be made. And that is how this particular standard product is to be made. So in general, the electromechanical machine are capable of a wider range of test speed and the longer cross-head displacement, whereas hydraulic machines are most cost-effective for generating the higher flow. So these are the two methods by which this particular tensile test is to be introduced and can be withstand. So according to the economy of that, according to the time range, these particular things are to be handled. So now, as we left that particular thing to the stress strain curve, and again now we reach to that particular point, that is what is that particular thing is to be done, and what are the role that particular thing is to be showing. So this graph is different from that graph. So don't be confused according to that. These are having some kind of importance. So what are these things? So a tensile test involves mounting the specimen in a machine such as those described in the previous section by that particular machine in the gripping, and subjecting it to the tension. When we grip that particular material, we apply the tension load, and then the tensile force is recorded as a function of the increase in the gauge length. And how it is to be recorded? That is showing the typical curve of a ductile material. Such plot of the tensile force versus tensile elongation could be of little value if they were not normalized with respect to the specimen dimension. And therefore, the engineering stress or the nominal stress S is defined as F upon A0. So A0 is the initial cross-section area of the gauge length, F is the tensile force, and that particular strain, engineering strain, is the E, and that is how this particular thing is defined as dl by L0, where the L0 is the initial gauge length and dl is the change in the gauge length. So when the force elongation data are converted to engineering stress and strain, a stress strain curve that is identical in shape to the force elongation curve can be plotted, and the advantage of dealing with this stress strain curve rather than load versus elongation is that the curve is virtually dependent of specimen dimension. So that is the very so, as I told you, this is the graph basically which is that particular thing is happening. Okay, so 1 minute. Right. Okay, so when pain was dislocated. Okay, so now that is the curve which is showing the behavior of that particular material. As you can see, the initiation of this particular in the elastic region is happening, which is showing in that particular. This is a standard one. That is how these particular things are showing. This offset is showing here that because it is not possible to find out where that particular limit of proportionality is to be happen, and that's why the total offset of this particular thing is to be taken care, and that's why this particular thing is showing here but it is not showing here. So this is very much finer in that particular. This is the original photo which is taking place. The load elongation curve from a tensile test and corresponding engineering strain curve specimen with the diameter of 12.5 mm and the gauge length of the 50 mm that is to be included. So that is how this particular that particular figures are from that particular thickness materials real life practical examples figure, and that is the standard based practical example figure. That is how this particular stress strain and ductility of that particular material is to be identified in that particular manner. So this is the basic base of that particular graph which is drawn in that particular shape. According, if we zoom on that thing, we will see that particular things, that particular thing. But it is at a very minimal condition in this particular scenario that the regions, that is the very basic regions, where is the concept. So these are the regions where that particular things are happening. So these regions are affiliated with this particular region. So that is how these particular things are. Sorry, these particular things are to be moving here. So what is happening when we applying some kind of a load? When we apply that load, what is happening? The elastic, the material have the tendency to elongate themselves in that particular elastic region, and that's how that they have the chance to, if the load will be moved, they will regain their shape, and that is how these things are to be take care of. That need to be taken care. So before applying that particular load, we need to identify that thing. So this particular area of that particular material is showing the elastic region, the limit of proportionality, that is the Hooke's law, stress is directly proportional to strain, and that is how this particular whole scenario of that particular graph is showing. So from that particular stress strain curve to that the elongation of that particular material to the yielding stress and strain, that how when we apply the load, how the particular material is behaving, and that particular graph is showing the constraint of that particular deformation or the elongation of that particular material. So what is happening in this, when we apply the load in the opposite direction, what is happening? What is happening? The particular material start moving in the elastic region first, and slowly it reaches to that particular range, that is called the proportionality range, and that is how we identify that is the particular elastic range. And after passing this particular elastic range, this particular material possessing the yielding, and that yielding is never allow this material to regain their shape again, and that is how the total elongation and the deformation in the particular ductile material is to be taking place. And there are lots of yielding points is available here, upper yielding, lower yielding. As you can see, this is the 2 point when what is happening with that particular upper yielding and the lower yielding. So when the material is moving up, how is that possible? It is moving down. So सब होता क्या है कि बेसिकली अगर किसी मटेरियल के ऊपर हम लोड लगा रहे हैं, तो एक टाइम ऐसा आता है कि वो मटेरियल अपने आप को अप्रिशिएट कर देता है कि भाई अब बस अब मेरे से कुछ हो नहीं पाएगा, और वो एक टाइम ऐसा होता है कि मटेरियल इस टाइम पर वो मटेरियल ग्रेजुअली अपने आप को इंक्रीज करता रहता है, बट एक सम टाइम ऐसा भी आता है कि कुछ उसके अंदर रेजिस्टेंस पावर होती है जो उसको लोड को बियर करने के लिए काम करती है. So at that point what is happening, that the appreciation of that material, that is the appreciation of that particular material is taking place, and that's why that particular downgrading of that particular graph is taking place. It is not as that much is showing here, it is just in the fluctuation. So this is the graphical representation, that is how that particular upper yielding, from upper yield to the lower yielding is happening. Because it's just because the material leave that particular scenario that okay, I don't have anything to do much to resist these things, now you have to. So that particular thing is dropped down that particular, and again the load is started to increasing, and that increasing load is extending to that particular ultimate tensile strength, and from where the necking is start, and that particular necking start from ultimate tensile strength, and the breaking of that particular thing is happen. And what we get from this particular thing, we get after the fracture that the particular material have that kind of tensile strength up to loading of that particular load. So जब टूट जाएगा मटेरियल तो हमें पता चल जाएगा कि इस मटेरियल पे इतना ज्यादा हम टेंसाइल लोड लगाएंगे तब जाकर वो मटेरियल टूटेगा, अगर उससे नीचे का लोड लगेगा तब वो मटेरियल उतने लोड को बड़े आसानी से बियर कर सकेगा. एंड इसी आइडेंटिफिकेशन के बिहाफ पे मटेरियल का सिलेक्शन होता है किसी भी मटेरियल को डिजाइन करने के लिए और प्रोडक्ट को बनाने के लिए. सो व्हाट इज दैट पर्टिकुलर इलास्टिक वर्सेस प्लास्टिक डिफॉर्मेशन. When a solid material is subject to small stress, the bond between the atoms are stretched. As I told you, all the material are made by this particular atomic arrangement, and that is how the stretching of that atom is to be happening, and then the elongation of the material is to be happening. So when the stress is removed, the bond relaxes and the material returns to its original shape. And how and when it is happen? It is only happen at the elastic deformation. In which region? In this region. That particular initial region. That particular elastic region. And that region also. This is the region. Okay. So the deformation of the rubber band is entirely elastic. आप कितना भी इसको स्ट्रेच करें और उसके ऊपर लोड लगाएंगे तो वो छूट जाएगा. Sorry. So at higher stresses, Plane of atoms slide over one another. This deformation which is not recovered when the stress is removed and it is served as a plastic deformation means they are now, suppose this particular atoms are arranged here. What we are doing? We are stretching that material. So during stretching, what is happening? The arrangement of that particular material is expanding. They are कहे तो एक तरीके से एक दूसरे को दबाने का काम करेंगे. आप खींच रहे हो तो वो दब रहे हैं, एक दूसरे को दबा रहे हैं. तो वो दबाने का जो काम होता है वो एक दूसरे के ऊपर जब चढ़ना शुरू होता है तो जैसे वो एक दूसरे के ऊपर चढ़ गए, जबरदस्ती एक दूसरे के ऊपर बढ़ गए. जैसे कि ये पर्टिकुलर एक सीट है, इस सीट के ऊपर हमने जबरदस्ती से 4 से 5 लोगों को सेटल कर दिया. तो वो एक दूसरे के ऊपर चढ़े हुए, फिर 5 लोगों को और डाल दिया तो वो एक दूसरे के ऊपर सेटल किए हुए हैं. तो अब होगा क्या कि वो फिक्स हो गए. अब उनका मूवमेंट जो है वो कहीं मूवमेंट होना पॉसिबल नहीं है. एंड दैट इज हाउ दिस थिंग इज शोइंग हियर इन द पर्टिकुलर फिगर. दैट इज द फिगर नंबर 5 which is taken. So what is happening? The plastic deformation does not mean that the deformed material is the plastic or a polymeric material. The bending of a wire, such as a paper clip within the figure, illustrated in the difference. So the wire is bent a little bit. It will snap back when released from the top. That is the showing of the movement. With the larger bend, it will be unbent elastically. And to some extent on release, but there will be a permanent bend because of the plastic deformation at the bottom. For most material, the initial portion of the curve is linear and the slope of that particular region is called the elastic modulus or the Young modulus, that is E is equal to S by E. So elastic and the plastic deformation of the wire with the finger with the small force, all of the bending is elastic and disappear when the force is released. With this greater force, some of the bending is recoverable in the elastic portion, but most of the bending is not recovered in the plastic portion. And when the force is removed, this particular thing is happening. Now, what is the yielding of that particular material in the low carbon steel? And then the steel are the many linear polymers, and the stress strength curve at the initial maxima, followed by the lower stress, as it is shown in that particular figure. And after the initial maximum, all the deformation at any instant is occurring. So that is the things. So within a relatively small region of the specimen, continuous elongation of that particular specimen occur by propagation of the deformation region. The lunar bands, that is called that the lowering of that yielding is called the lunar band. And along the gauge section, rather than by the increased strength within the deforming region, only after the entire gauge section has been transferred by the band does the stress rise again. And that vibration, when that particular material appreciate themselves, and then the vibration of that particular material is taking place, and due to that, जैसे कहे तो कोई किसी को अगर आप लोड लगाया जा रहे हैं तो वो एक तरह से बेहोश सा हो जाता है और अचानक से उसको होश आता है तो फिर वो उस तरह से लोड लगाना शुरू उसी क्रम में काम करना शुरू कर देता है. And that the thing is happening in this particular graph, and that is the particular yielding is showing that particular lunar bands, which is the lower yielding strength of that particular material. So yielding strength is often defined as the initial maximum stress, or still the subsequent lower yielding strength is used to describe the yielding. This is because the measurement of the initial maximum or upper yield strength are extremely sensitive to how axially the load is applied during the tensile test. So in the some laboratory side, the minimum, whereas other side, the mean stress during the discontinuous is yielding. So the tensile strength, that is the ultimate strength, is defined as the highest value of the engineering stress up to maximum load. The deformation should be uniform along the gauge section. That the point need to be marked. And they start with the localized forming a net less ductile material fracture before they net. So in this case, the fracture strength in the tensile strength, indeed the very brittle material as a glass at a room temperature do not yield before the fracture. These are showing this various figures. So that particular such materials are taking place in that particular figure, which was earlier, which I showed the mention and that particular name. So some of the most important consideration which is involved in the tensile testing, these include the sample selection. That sample selection is to be taken care by that particular ASTM standard. And the sample preparation, okay, it is followed by that particular ASTM standard. And the test setup and the test procedure is also according to that ASTM standard, that how that particular material to be tested. And then the data recording and the analysis of that particular thing, and to be reporting that the two parts are taking place by the taking the data of different kind of a test which is made by that particular material, which is happening by that particular material on that particular material. So the sample selection, when a material is to be tested, the objective usually is to determine whether or not the material is suitable for its intended use. The sample to be tested must fairly represent the body of the material in question. So जो भी मटेरियल को हम टेस्ट करने जा रहे हैं वो ऐसा होना चाहिए जहाँ पे जिन पर्टिकुलर प्रोडक्ट में हमें क्वेश्चन मार्क दिख रहा है. So you can say in the other word it must be from the same source and have undergo the same processing step. ऐसा नहीं कि किसी दूसरे प्रोसेस से बना हुआ मटेरियल को हमने टेस्ट कर लिया और बोल दिया कि हाँ ठीक है, ये जो मटेरियल जो बना हुआ है सारा लॉट ये ऐसे ही है. सारा कुछ एक प्रोसेस से बना होना चाहिए, एक समीकरण से बना होना चाहिए, एक कंपोजिशन से बना होना चाहिए, और उसी कंपोजिशन से बने हुए मटेरियल के अलग अलग पार्ट्स में से अलग अलग जगहों से उस पर्टिकुलर एक स्टैंडर्ड पीसेस को निकालना होगा और उसके बाद पर्टिकुलर मटेरियल को सिलेक्शन करना होगा. देन वी प्रोसीड फॉर दैट पर्टिकुलर टेस्ट. ऐसा नहीं कि जस्ट एक मटेरियल को एक जगह से काट लिया और पूरे मटेरियल को हमने कह दिया कि यस इट इज ओके. ऐसा हो सकता है कि आपने अलग अलग मटेरियल को अलग अलग उस मटेरियल को अलग अलग तरीके से बनाया होगा, तो उसके बनाने के क्रम में कहीं ना कहीं चेंजेस आए होंगे. कभी कहीं लोडिंग ज़्यादा हो गई होगी, कहीं कहीं कूलिंग ज़्यादा हो गई होगी. तो वहाँ पे क्या चेंजेस हो रहे हैं, उस पर्टिकुलर एरिया पे क्या इफेक्ट पड़ रहा है. एंड दैट इज व्हाई दिस पर्टिकुलर नेक्स्ट पॉइंट इज मेंशन्ड हियर. इट इज ऑफन डिफिकल्ट to match exactly the test sample to the structure made from the material, and that's the problem. A common practice for testing of a large casting that we forget by which particular material is related to that particular casting. Fourth thing, and the composite layers is to add extra material to part of the building test sample. So that is why it is that particular point it needs to be taken care. So this material is cut from that complicated part after processing and is to be made into test specimen. They have been subjected to the same processing step as the bulk of that particular part. And in the practice, the these specimens may not exactly match the bulk of the part in a certain important detail, such as the grain pattern is critical area of that coaching, which I told you. कहीं पे ज़्यादा लोड लग जाएगा, कहीं पे कम लोड लगेगा, तो उनका जो ग्रेन स्ट्रक्चर होगा वो चेंज हो जाएगा. तो उस ग्रेन स्ट्रक्चर की वजह से वहाँ की स्ट्रेंथ चेंज हो जाएगी. तो ये छोटी-छोटी बारीकियों को ध्यान देना बहुत जरूरी है. One or more complete part may be sacrificed to obtain the test sample from the most critical area from the comparison within the built-in sample. So that this is may be determine how closely the built-in sample represent the material in the question. So there is a sample case in which the object of the test is to be evaluated, not the material, but the test itself, where the test specimen might be nearly identical as possible. So the difference in the test result represent as far as possible only the variability of this particular test is to be processed. So these things need to be taken care, and we will discuss this in detail more in the next lecture.